Good afternoon, everyone, and welcome to the very first masterclass of Target Elevate 2021. I'm Shree. I work as a director of technology at Target in India, and I'm responsible for Target's core commerce platforms. I'm super excited to be hosting this session with Dan, one of our distinguished engineers. The term distinguished is often used to describe someone who stands out from the pack, a game changer, author, innovator, and a man of many talents. Dan leads enterprise-wide technology initiatives at Target. With a bird's eye view on what happens at Target globally, he is all about thinking big and pushing tech into uncharted spaces. He's also written an O'Reilly book titled Learning Rat Pack. Anyone who interacts with him will discover his strong passion for software development. In the masterclass today, he draws from his experience leading technology initiatives at Target, Netflix, and at presidential campaigns on what thinking big in tech entails. And he's also up at 4 a.m. this morning to talk to us, and hopefully has had some really strong black coffee or a few mugs of it. Let's give a very warm welcome to Dan Woods.
An inflection point will inevitably come in every developer's career where their scope of understanding expands beyond the local domain of their product, team, or area and into the super domain of the enterprise. Naturally, developers who can reason about the complex inner mechanics of the various systems that power an enterprise will be called upon to weigh in on difficult problems that span business tiers, organizational portfolios, and technical implementations. These are the enterprise engineers who are able to see the big picture when considering a change and able to drive cohesion in technical solutions. But they're also the group of people who curry organizational behaviors, stand as role models for others in the organization, and shape the engineering culture for the entire enterprise. With elevation comes clarity, with clarity comes vision, and with vision you can see the road and stay the course on a multi-year engineering initiative. In this talk, I'll share with you my perspective on being an enterprise engineer. Before we dive in, I want to give you a little background on my experience. I work at Target today as a distinguished engineer in infrastructure. I'm an individual contributor, and most of my work is spent on enterprise-wide initiatives or projects that will affect engineers across the business. I joined Target in 2017 as a principal engineer in the store space, where I worked to build a distributed platform for deployment systems for applications running in our 2,000+ store footprint. From there, I moved to infrastructure in my current role. I left Target in April of 2019 to work on the Biden for President campaign as Chief Technology Officer. This was a management position, and over the course of the primary election season, I built the best technology team in politics. Prior to joining Target in 2017, I worked with an organization called The Groundwork, which built the technology platform for Hillary Clinton's presidential campaign in 2015 and 2016. I worked as an individual contributor and was responsible for building continuous delivery and cloud tooling. Before all of that, I worked at Netflix as a senior software engineer and helped build out the popular open source continuous delivery platform called Spinnaker. Now, most of my career has been spent working in technology infrastructure, which inherently requires a bird's eye view of the enterprise. Whether making decisions about how networks are interconnected, planning compute capacity for the next year, or building enterprise-wide deployment systems, nearly every decision in infrastructure requires an understanding of how the systems are being used. And it's important for you to get it right at this layer of the architecture because infrastructure investments are slower moving than other technology just by their nature. However, the premise of being an enterprise engineer does not only apply to the lowest level of the technology chart. Indeed, the complex requirements of a business use case that span multiple technology pillars is another area where an enterprise perspective is needed. As you, an engineer, consider an implementation that requires changes across multiple technologies, you can also consider the following 3 dimensions in your decision-making process: simplifying, standardizing, and observing. The biggest threat to an implementation at the enterprise level is complexity. Complexity can manifest in many forms, through differing communication protocols, differing technologies, or disparate local architectures. When you zoom in on the individual architectures that make up a broader enterprise architecture, it is important that you're also able to distill the functionality of each component to its core capability. When thinking about the bigger picture, simplicity in the individual components gives you 2 important things. First, it gives you the ability to easily change a component later as business requirements change. This is especially important in industries like retail, where the business use cases evolve irrespective of the implementation of a feature. When more features are added to a component beyond the scope of its original intent, it becomes exponentially more difficult to change this portion of the architecture later on. The second thing simplicity gives you is an emphasis on reliability. Following the single responsibility principle in software design, we require components of an architecture to do one thing and do it very well. This rule applies to everything from the concrete implementations of an interface to the constraints of an individual microservice, and all the way up to the collection of multiple microservices that comprise a distributed system. Functional programming has become a trend in software development because it follows that simplified paradigm. For any given input in the code, it will always produce the same output. As an enterprise engineer, think about yourself as someone who is building a city out of Legos. The simpler the component pieces, the easier and more stable it is for you to build upon and reason about as the plan grows. Now, no engineering initiative is a small feat, which means that it includes the cooperation of multiple teams and likely across multiple years of effort. Expanding on the Lego metaphor a little bit, Legos work as a great primitive, single responsibility component because they have a common protocol for how the bricks connect. The same logic and rationale can be applied to software engineering projects, both for the technology and for the engineers involved. You may need to look at standardization from the standpoint of being able to reason about how a request flows through a system. For example, when implementing an architecture where component B makes a call to components A and C, you might find it beneficial to standardize on a RESTful HTTP contract between services so that you can pass data in headers up and down the chain of microservices. Standardization of technology across services and teams reduces the possible number of options, which ultimately contributes to simplicity, but it also improves team velocity and applies to economies of scale. Economies of scale take shape when considering the broader ecosystem of supporting technology, like CI/CD systems, developer IDEs, and supporting libraries. By standardizing on a language, a framework, or even a design pattern for how components are implemented, you remove the guesswork for developers who are zoomed in on low-level implementation. Another way you gain economies of scale is in how developers can contribute across the enterprise. When developers have a common understanding of the technology footprint between components, you enable developer mobility. This means that you open new avenues for developers to contribute and create inroads for more specifically focused engineers to start seeing and thinking about the bigger picture. Ultimately, standardizing technology across the enterprise further contributes to simplicity. When looking from the vantage point of the enterprise, you may easily identify common implementations repeated across components. You can factor those repeated implementations out by building a common set of libraries. The third and final dimension to consider when building a technology solution for the enterprise is that of observability. You cannot understand a system unless you can measure it. The technology of an enterprise is a conglomerate of cooperative systems, each collaborating on an individual piece to a bigger capability. To truly reason about the operation of the holistic system, you must be able to see the motion of each turn in the system. This means being able to observe a comprehensive view that covers the overarching capability of the architecture, the business use case, all the way down to the individual components that are the Legos to the city. Simplicity and standardization contribute greatly to the dimension of observability. By keeping components focused on their single responsibility, you're able to easily reason about what you observe when you're zoomed in. By standardizing the technology across components, you're able to build comprehensive insight that is common across cooperative systems. As an example to all of this, at Target, we built the Target application platform, TAP, to serve as both the deployment system and runtime environment for microservices. From TAP, we built a set of lightweight libraries for standardized sets of technology that we support. We support JVM-based systems and have platform support for Spring Boot and Ratpack web applications. When developing an application of these types, developers incorporate a platform connector library into their project, which ensures that every application is emitting a common set of metrics across the enterprise. From this, we've been able to develop comprehensive insight and understanding of things like CPU usage, memory usage, network throughput, but also an understanding of how applications function, including from HTTP status codes, request latencies, database call metrics, and so forth. This overview into the operation of the applications across the enterprise allow us to produce a business understanding for everything from buying more servers to understanding how microservices interconnect in the architecture. Likewise, other enterprise engineers can build off the standardized set of metrics each application produces to build a comprehensive understanding into their business function across a distributed system. This has been critically important to our success in building enterprise-wide distributed systems over the last several years. Each of these dimensions in being an enterprise engineer should be rolled up under the intention of durability and flexibility for the future. A good motto to follow is opinions, but loosely held. What it means is you're making technical decisions based off the best information you have available today, but with the understanding that things will need to adapt and change in the future. One of the best pieces of advice that I can give to enterprise engineers today is this: do not be afraid to throw away code. Code that you implemented yesterday was built with the understanding from yesterday. If your understanding of simplicity or standards change, you should be ready to adapt the implementation to your new understanding of things. Ultimately, when building for the enterprise scale, the foundation of any system is the abstractions upon which it is built. Abstractions can exist at multiple layers in the implementation. For example, when modeling the functionality of a system, you have a set of data that needs to be captured through an API, which then gets passed back to a service tier that interprets the data and makes a decision about some work that needs to be done. This API is now your abstraction layer. The data you capture through your API is your domain model. And with both of those things in place, you can easily change and trade implementations as you further simplify and standardize in the future. At Target, we began our journey to a full microservice environment by focusing on the underpinning technology that stateless services could run on. We built a large Kubernetes environment and gave developers access to it to deploy their services. Kubernetes manifest files were spread across code repos for literally hundreds of projects. What we quickly realized is that having the applications interfacing directly with the infrastructure meant that we had made it very difficult to change the underlying implementation later on. We learned the hard way that we really needed an abstraction layer between the applications and the infrastructure implementation. We started the years-long journey to a robust deployment system by defining the set of data we needed to capture about a microservice so that we could appropriately communicate deployment logic to any number of back-end deployment infrastructures. Indeed, the journey was difficult, but because we had so many microservices that had built their delivery workflow around direct access to the infrastructure. So what we did was we built a system that we call the Platform Intelligence Engine, or PI for short. PI sits at the center of the TAP architecture and is arguably the most important component in TAP because it is the abstract API that we use to transform details about a deployment into the actual action of performing the deployment. Initially, behind PI sat just a single Kubernetes cluster. Since we knew how well Kubernetes was being used, we could easily model the intended behavior of deployments in TAP based off of how deployments were already being done. With PI as our abstraction layer, we were able to change out the underlying Kubernetes implementation without requiring any changes to the code repos for the thousands of applications ultimately that were being deployed on TAP. This is where the intelligence part of PI comes in. PI was then responsible for managing the distribution of deployments across backend clusters. This allowed us to get really smart in how we made fundamental changes to the infrastructure, and we were able to make these changes safely and without requiring involvement from application teams. TAP has allowed us to encapsulate the low-level details of the infrastructure and has let us focus on the core data domain of describing continuous delivery for microservices. Over time, having this abstraction paid dividends for us by allowing us to develop a more efficient application runtime where we were able to push higher utilization of servers for a lower overall cost. At the end of the day, TAP has drastically simplified our enterprise environment by decoupling applications from the infrastructure. It has standardized how services are bootstrapped and deployed, and it has been the vehicle for improving our observability into the environment. Furthermore, we use TAP as a means to improve the overall developer experience for all engineers in the organization. When we started TAP, we wanted to make sure that we had a North Star that we were working toward across the many teams who were involved in the implementation. Although we knew we'd benefit from simplicity, standardization, and observability, we also knew that since infrastructure is so fundamental, we had the opportunity to make a positive, meaningful change in the day-to-day of every application developer at Target. Our goal for improving the developer experience from the outset was simple. We would evolve a set of ingrained processes for obtaining infrastructure into a fully self-service model. That way, we knew we could reduce friction and increase velocity for developers who just wanted to write some code and see it live. To keep true to our North Star, we came up with the saying of the midnight developer. Now, the midnight developer is a developer who is working diligently to get some code written, deployed, and see it up and running. She should be able to set up a new project, a new CI/CD pipeline, and see her code up and running without having to wait until somebody in infrastructure was online the next morning. As we built out the supporting systems in TAP, the idea for the midnight developer followed along at every step. This allowed us to keep our focus on the goal of enabling improved developer productivity as we built new systems and processes. Ultimately, I think humanizing the work to someone we would consider a peer and colleague helped constantly remind us that on the other end of this project, there were real people whose lives we would be impacting. I realize the infrastructure conversation doesn't necessarily apply to everybody, but the concept of controlling your destiny with a set of healthy abstractions will. By defining the abstractions in your system, you take control of the implementation detail, and ultimately, what you will need to grow and adapt any technology solution as the needs of the business also grow and adapt. Now, arguably the most important piece I will discuss today is the reality that although we're building technology solutions for the enterprise, we're working toward that goal with people, real life human beings. And human beings are not computers. They have feelings and emotions tied to their work and how they do it. Inevitably, you'll find yourself in a situation where you need to make a judgment call on standards of technology or scope of an individual service. And that call may run contrary to the ideas of others in the organization. And that's okay. As I said at the beginning, as an enterprise engineer, you're responsible not only for the technology, but also for defining the engineering culture of the organization. Make sure to open space for people to contribute along the way, have impassioned debate, and do it with empathy for the engineers and leaders you work with. As good as a healthy architecture and technology implementation is, having a healthy engineering culture is equally important. Make sure you carry with you empathy as one of your most important tools in your tool belt. Now, many of you may be at a point in your career where you're wondering whether being an individual contributor or going into management is the right decision for you. I've had the opportunity to do both, and I think the truth I found is that it doesn't need to be a binary decision. The fact is, over time, you develop qualities that scale the two disciplines. Make no mistake, switching from one to the other changes your day-to-day, where you contribute, and how you solve problems for your organization. But what doesn't change is your approach to difficult problems, how you influence outcomes in the organization, and how you lead the people around you. What ultimately you should consider is, in what domain can you grow that will fulfill you most as an individual? If you feel spending your time architecting technical solutions and driving projects will give you the most reward right now, then you should be an individual contributor. If you feel you'd get the most reward from having the experience of working to help others grow and unlocking opportunities for them to be successful, then a management track could be right for you. Whichever way you decide, it's okay to change it later on. And that's an important thing to understand. As you grow and learn more, you can choose the path that works best for you at the time. Sometimes I talk to people who are on this journey, and they're concerned that if they go into a management position, they'll somehow get rusty and lose their skill. And while it may be true that you wouldn't be able to dive right back into the latest cutting edge technology, your technical mindset for problem solving won't be rusty, and it'll get you back on track really quickly. So in closing, I want to thank you very much for sharing this time with me and for thinking about how we can approach engineering at the enterprise scale.
Thank you, Dan. That was a very insightful session. We do have some questions from the audience, but before we start with them, I have a question or two of my own based on what I just heard. Like as you were talking, the impact that you've had in your last roles has been big, whether it's been at Target or outside. So can you talk through a little bit on when you have a large problem? How do you start understanding the moving parts? And how do you ensure that the solution has abstractions at the right level?
Yeah, it's a really good question. I mean, I think the first thing to do for any kind of big project is to look at what's already there. So, you know, especially at big enterprises like Target, a lot of our solutions are not necessarily going to be greenfield. They're not going to be brand new. So there have been solutions and implementations that have solved the problem in the past before. It's incredibly important, I think, to get that understanding of what the legacy systems are, not only so that you can understand what's already in place, but I think also so that you can understand how the team and how the organization has approached the problem in the past. That's where I would plan to start. And then from there, I think you can sort of follow those principles of simplicity and standardization and start to figure out what can be factored out, what can be reduced, and what needs to be new technology from there.
Thank you, Dan. That was very helpful. You spoke about the Target Application Platform, or TAP as we refer to it. You conceived it, helped build it, had it adopted widely in a sprawling enterprise. You were an individual contributor while you did all of that. So how does one do that? Influence change, big one, as an IC or an individual contributor?
Yeah, sure. I think the biggest answer to influencing change as an individual contributor, as somebody without explicit authority, is by being able to help drive the conversation about the next discussion. What's going to be the next discussion? And in the case of TAP, we were trying to solve a couple of different problems from a couple of different angles. At the time, we had a very manual developer workflow. We wanted to improve the developer experience, like I talked about. We had a utilization problem of compute. So we had a lot of servers in our data center that were not being fully utilized. And one of the things that we wanted to do as part of our platform engineering effort was be able to build a system that could better utilize, or at a minimum, be able to better understand how the servers were being utilized. What were the applications doing on those servers such that they weren't using 100% of the compute environment? So, I kind of looked at it, and to be clear, I didn't do this alone. I didn't come up with this alone. It was a lot of conversation and architecture and so forth. But we looked at the environment, and we looked at the problems that we were trying to solve, and we said, what we need to do is we need to build some abstractions so that we can essentially take control of the infrastructure. Like I said at the beginning, we had applications that were fairly tightly bound to the infrastructure. And that didn't give us a lot of mobility. It didn't give us a lot of capability to change. And what that had resulted in for the application teams, for the developers in the rest of the business, was periodically, actually quite frequently, infrastructure would go to them and say, hey, we need to change the infrastructure, so we need you to rewrite your applications. I think anybody from Target will understand the concept of replatforming. And it was extremely painful. And one of our goals out of the whole thing was, let's improve utilization by understanding what's going on. Let's simplify the implementation behind the scenes so that we can change the infrastructure behind TAP without a lot of effort. And then from there, let's improve the developer experience. So let's not make it so that folks who have deployed applications onto TAP have to come back in another year or 2 years and change stuff. So that was how we approached the problem. But the answer to being able to influence the change, as a part of those conversations about what are the problems that we have in infrastructure, I was able to keep bringing this up as a solution, right? Not in hopefully not in a repetitive or annoying way, but more in a way of saying we have an opportunity here that we can solve a number of problems by going with a specific architecture, a specific implementation, and I think over time people were able to understand that a lot better, and the idea got traction and it got movement, and we were able to go from there.
Thanks, Dan. That was very helpful indeed. You've been at Target, Netflix, and led technology teams for presidential campaigns. These seem to be very, very diverse as roles go. What, according to you, was similar? What was different? And what learnings have you been able to take from one role to another?
You know, the continuity in industries is definitely the technology, without a doubt. The you know, I've spent most of my career working in infrastructure, which is you know, I want to say kind of a niche area to work in. Um, but it's also something that every company needs. Every company needs help in one way or another. The role that I have in infrastructure at Target is different than the role that I had at Netflix, because at Netflix we were full cloud. At Target we have probably every compute environment that you could imagine. But the principles of what we're trying to do don't change, right? And that's also true through through the work of politics as well. Is what we're trying to do is we need to write software, we need to deliver software, but at the end of the day, we need a system that can help us facilitate change, right? And that can come in the form of software, um, or it can come in the form of just making the developer experience a lot better for the people in the organization. So that's kind of the continuity between them. But besides that, I think there's something really big to be said um, about being able to solve big problems, right? Being able to look at a big environment, and not be overwhelmed by what it is that you see, and be able to affect meaningful change in that kind of world. And I think in many of the roles that I've held over the last decade, that's been sort of a big muscle that I've had to develop.
Thank you, Dan. In your talk earlier, you spoke about empathy while building a technology solution. That sounds fascinating. So, can you give us an example of how to make that happen?
Yeah, sure. So the most, I would say the most obvious example of where we need empathy is the example that I gave, which is that developers are developers get really attached to their code, right? You build something, they're very proud of it. That's great. That's an incredibly good quality to have in developers. So it's important to understand when we're looking at solving a problem at the enterprise layer, especially one that might obviate the need for a specific implementation that already exists, or to move something from legacy out and bring in a new implementation. It's so important that you understand that there are people who are invested in the pieces that are there, and in doing so, it does help you humanize the software, right? Because like I said, people are not computers, and that's maybe the biggest lesson of all of them. But what that means is that you need to, what I found has been successful for me anyway, is taking a moment to really truly understand the work that other people have done. And you don't need to go all the way to the ground level. You don't need to understand every single line of code, but at least understanding how they've approached the problem, and understanding the level of effort that they put in and the work that they put in. If you can demonstrate to an engineer that you have taken the time to understand the work that they've done, it's going to go a really long way when you say it needs to be changed. And being able to demonstrate that, I think, care and respect for the people that you're going to be working with is so critically important. The other thing I think is, when you're working with leaders in an organization as an engineer, as an individual contributor, it's, I think when we're talking engineering architectures and when we're talking engineering implementations, it's really easy to get into the weeds, and it's really easy to get hung up. And it's so important, I think, when you're trying to communicate these really big architectures and ideas, that you understand that sometimes the people who you're talking to are not going to have that same depth of understanding. And being able to walk through an idea and start simple and sort of work toward what the lower level details are along the way. What you do is you end up taking people on this thought exercise, this thought journey with you, and I think it goes a long way, because what it means is at the end of the day that everybody that you're working with is going to have a fundamental understanding of what you're trying to do. Now they might not understand the implementation or the mechanics, and that's okay. But if they understand the direction of travel and why you want to do it, that just shows, how much you're interested in bringing the rest of the organization with you.
Thanks for that, Dan. We do have a few questions from the audience. Pratima Bose from Scientific Games has a question. Pratima, would you like to go on camera and ask the question yourself?
Hi, Dan. I hope I'm
Hi.
audible. Yeah. It's wonderful to listen to you from an accomplished influencer and contributor. I'm so overwhelmed right now. I have a question to ask. My question is, should technology reflect linear thinking or lateral thinking to be able to empower community?
Let me think about that a little bit. Can you expand a little bit on what you mean by linear and lateral?
It is like, should it be logical with reasoning? That's what linear thinking is about. And lateral, what I meant is, should it be practical? Not
Well,
really based around rules and yeah, that's
yeah.
it.
No, that's a great question. It's a little of both, right? On the one hand, and it kind of goes to the conversation of empathy and software development also, I think, because at the end of the day, you need to deliver an outcome, right? And you need to deliver an implementation to an architecture that you come up with. At the same time, you need to do it in a way where you understand that there are bigger mechanics than just software involved. So, thinking about it from the logical standpoint, the strict, this is a system that we're developing, and and it has an implementation detail, and it will be deployed. It will be live in the environment. So we need to go and build it, right? But then on the other hand, and I think what you're actually getting at is what does the implementation detail look like, right? The software itself can be flexible, and I think that that's important. I'll give you a really good example. When I was working on Spinnaker at Netflix, what I knew is that we wanted Spinnaker, or one of the design goals of Spinnaker was to be multi-cloud. We wanted to build a deployment system that was able to deploy to the various clouds. And this is back in 2014, by the way. There weren't very many, so it was kind of easy to say, we'll deploy to one of the 3 clouds. But what we also knew during that time was that the maturity of things like Google Cloud and Azure, and I don't even think it was called Azure at the time. I think it was called Microsoft Cloud, and Oracle had an emerging cloud. They called it Oracle Cloud. And IBM had one, and there were more anyway. But what we knew was that they were going through a process on their own side of figuring out what it was that they were going to do. And we didn't have all the answers, and we didn't have all the details, but I wanted Spinnaker to remain very flexible. And so as GCP changed, and as AWS changed, and as Azure changed, I didn't want to have to change too much about the mechanics of Spinnaker just to make the new parts go along with it. And so there's a big part of Spinnaker in the deployment pipeline where it's just a map. It's just a Java map of data, and it's untyped and it's unqualified. And anybody who's written Java code will tell you that the reason that you would write Java is for the type safety. But I wanted it to stay flexible, so I specifically did not include type safety, just for that one part. And I think that ended up giving us a lot of flexibility. So that's sort of that lateral capability that you described, right? But then there is a very, but that kind of takes away a little bit, I think, from the linear side of things by by just the nature that because it was untyped and because it was very flexible, it wasn't super easy to understand. And I think if you talk to any Spinnaker developers, they would tell you, they would probably say bad names about me and stuff like that because of what I did there. But I think you can apply the weighting, you know, to both how you approach the architecture and also how you approach the implementation. I think it's a balance of both.
Great. Thank you, Dan. Thank you. That justifies.
Thank you.
So I know a number of my peers on this call would love to ask this question, so I'm going to ask on their behalf. If you're interested in remaining with code tech, coding, creating, building new things, how can you still build a progressive career, yet remain true to your trade?
The biggest thing that I can say is to build and to keep building and don't stop. Nothing replaces hands-on experience. That's true for any role, truthfully. Whether you're an engineer or a manager, you know, you can understand something very well, but until you do it, you haven't developed the muscle memory, right? The capability. For technology, for staying in a deeply technical role, the best thing that you can do is deliver software. And I can't emphasize that enough. Don't just build the architectures, build the implementations and get them out there. And the hardest thing that I have in giving career advice to engineers is convincing them that it's okay to be wrong. It's okay to not have the perfect implementation, and it's okay to not have all of the answers of getting to the end, you know, before you actually build something and get it out there. So much of the work that I do in the implementations is building that sort of progressive experience so that by the end of it, you know what are all of the dark corners that are awaiting you on the map, right? And you've seen what the destination can look like. And then what you need to do is, once you've done that, go back to the beginning, and now you understand one of the roads that you can take to get to the end. So you have a surefire way to get to your destination. But then what you can do is you can start throwing away pieces of software, implementations that you made in the moment that you were building up your understanding. And ultimately, I think what that gets you is a sharper knife, right? To use yet another metaphor, but you hone your skills more than anything. And the more that you do that over and over and over again, you know, just the more natural it becomes. And that's, I think, how you ultimately stay sharp. And by virtue of being sharp, and by virtue of having sort of a bigger picture thinking about the problems that you're trying to solve, you end up developing that progressive career. You progressively solve harder and harder problems, and as through the nature of solving harder and harder problems, you grow your career, you evolve, and that's how I would say you would continue to grow as an IC.
Thanks for that, Dan. It was an amazing session. Thank you for being here and sharing your experience with all of us. I'm going to try and summarize this into a few key takeaways. While building tech solutions that have a big impact, think of simplicity, standardization, and observability. Be mindful of what you build. Always have the bigger picture in mind. Empathy in tech is essential for influencing change. And finally, you can be a leader and a great developer at the same time. With that, we come to the end of this masterclass. Thank you, everyone, for joining us today. But before we wrap up the session, we'd love to hear from you on how useful you found this. There's a link on the chat coming up. Do share your views there. They're just 3 questions, not 30, so it's really short and sweet. There's plenty more in store through the week. And don't forget to join us for the grand finale on Thursday. We've got some great conversations lined up. Bye for now.